standing waves. Okay, so what we were studying in the lab is actually standing waves. So when you were trying to make those different number of half wavelengths, all right, if you got it just right, you managed to get this pretty wave that was fairly consistent and not just a pulse that was traveling through. So let's talk a little bit about how that happens. All right, at a fixed end, right, just like we learned before, an incident crest becomes a reflected trough. So if I repeat the process periodically, and I get my timing just right, so every time I'm going to get constructive interference, then I end up with this really pretty standing wave. All right. Just a reminder about nodes and antinodes. Here are the definitions again, and here's a picture of where these are in a standing wave. Okay. This leads us to a discussion of harmonics. So the first harmonic is what you initially made with just one antinode in the middle of the string. So this one is very similar to a plucked guitar string. This will eventually be where we go when we start talking about harmonics and their real-life uses. So the second and third harmonics, all right, look like this with two antinodes and then three antinodes. Sensing a pattern here? The number of their harmonic equals the number of antinodes, or number of, half wavelengths. So let's look at the relationship between harmonics and wavelength. So this animation is going to go through a couple of times, all right? So we'll watch it, and then we'll talk about it. So a complete wave starts, all right, at the beginning and finishes at the end of one wavelength. So there's two loops in one wavelength. So each loop is half a wavelength. All right, so we saw that yesterday. Okay, and then here's the relationship you developed in class. The nth harmonic, right, if you take that length, you fit the number of half loops, all right, divided by 2, equals times the wavelength. Otherwise written as a wavelength is 2L over N. That's a lot more useful.